Section 2.1, representing integers, deals with showing integers in a variety of different ways using integer tiles. First of all, we have a red and a yellow tile. And the easiest way to explain it is that red will represent negative. Sometimes you'll see it like that, sometimes you just see the minus, but negative numbers. These ones here, the yellow ones, will represent positive numbers. So in the very simplest of way, if I were to say this would be plus 1. If I were to do 2 of these, it would be plus 2. And the opposite is true as well. If I put 1 of those, it would be minus 1. If I put 2 of these, it would be, very simply, minus 2. Okay. So you can represent any number, positive or negative, using these blocks. So if I said represent the number plus 5, I would have to show that by getting 5 of these blocks. 1, 2, 3, 4, and then I'm going to need one more to give me 5. There. So I've got 5, 1, 2, 3, 4, 5, so that represents plus 5. Okay. One last thing. If I go over and I take a positive and a negative number, let's say I take one of these, and let's say I would take another one of these. When I put the two of them together, this one here, this minus 1, and this positive 1 will cancel each other out. Okay? And they will cancel each other out, and they will give you 0. They'll give you nothing. Okay? So they will cancel each other out. Remember, they're opposites. Okay? They are total opposites, and they're arch enemies, so they'll always end up canceling each other out. So just group them together when they are in the same problem. So if I ended up with, well, first of all, they get a name for this. This is called a zero pair. And those zero pairs mean, or they represent, nothing. You can have as many zero pairs as you want, and it'll still be nothing. So if I were to take, say, another couple of these, and I could do this, this represents nothing. If I get another one, this still represents nothing. Another one, this is still 0. Another one, this is still 0. Okay, they represent nothing when you put them together, of course. Okay, so that's why they're called zero pairs. So let's try to represent minus 6 in two different ways. Well, the easy way to represent minus 6 is to just simply take 1, 2, 3, 4, 5, 6. Now this here will represent minus 6. Now how can we represent it in another way? Well, remember what we said. If you put one of those and one of those together, they really mean nothing. They're zero pairs. They cancel each other out. So I could take what I had before, this one right here, and I'm going to put it right down below and then add a zero pair onto it. I'm going to circle my zero pair just to show that they cancel each other out. Now, can I show another way to represent? Well, it only asked me for 2, but if I wanted another one, I could start with my minus 6, and then I can add another zero pair. So I'm going to add another zero pair. I'm going to get rid of this here for now. And I can add another zero pair. and another one, and another one. I can keep going forever. And that's still because all of these cancel each other out. I will circle them and then just count how many I have. This is minus 1, 2, 3, 4, 5, 6. This here whole thing still represents minus 6. So when you're asked to represent a number in two different ways, that would be how you would represent a number. Using your zero pairs makes it easy. So how can we represent 0 in two different ways? Well, the easiest way, take one pair of those, because we know that that represents 0, because there's 0 pairs. Can we do another way? Well, sure. Take one of those and one of those, it's still 0. Take another one of those, that's still 0. I can circle it just to show how they cancel each other out, and the answer is 0. So there's lots and lots of ways you can keep representing numbers. So how will we represent a plus number in two different ways? Well, one way to do it is the easy way of just putting 6 of these tiles down. 4, 5, 6. That's the first way, not using any 0 pairs. Now if I want to do it again, I can put down my 6 tiles, and then I can add some 0 pairs to it. I'm going to have to copy a few more. One there, and one there. So that's another way to represent. And I will circle my 0 pairs. So I have 1, 2, 3, 4, 5, 6. So it's plus 6 for this entire thing. And this is also plus 6. So that's two different ways to represent a positive or plus 6. Alright, so now I'm giving you one that is not, it's unknown. We don't know what this number is. So how do we figure out what this number is? Well, first thing you do is you start circling the 0 pairs, the ones that cancel each other out. So that one and that one cancel each other out, and what's left when you can't cancel out anymore, you have 3, 1, 2, 3, and they are yellow, so they are positive 3. Moving down to the next one, first thing we do, we cancel the 0 pairs out. And how many do we have left? 1, 2, 3, but this time it's 3 red, so it's negative 3. And finally, just to kind of prove a point here, going down here and looking at this last one, let's see what cancels out. Well, if I keep circling them, you can see what's happening. All of this, when I circle my 0 pairs, will give me, in the very end, a big, fat, juicy 0. It's not a positive, it's not a negative, it's just 0.